I hope everybody is here with me. If you are facing any issues regarding the course content or course website, please take a pause and please listen to this first presentation. This will help you to get connected with the course, and then I'll give you enough time to get started with the course. We will do the lab practicals in the course website together. So please focus here in the PPT. Also, I want you to have some fun while doing this course, because fun way is the best learning way. And the technical term for learning while having fun is called relaxed alertness. We humans have a gate kind of thing between when we are executing some task versus when we are training or when we are predicting. Okay, so how it works is humans have these two phases: rest and digest, fight or flight. When you're learning, you're in the phase of rest and digest, and when you're performing what you learn, or when you can take it an example like when you're learning in your classroom, you are resting and digesting the facts that you're learning, and then in your exam you might be performing like fight or flight mode. Similarly, machines also are trained in this way. There are two phases: training and prediction. We will see how it works. Starting with a brief history of AI, how it started. I'm not going to teach you about the entire field, but we will start with a brief history. And looking at this diagram, what you can think is computers are made in part to complete or to augment our human tasks, to help us, right? That is the purpose that we build computers. But beyond certain capabilities, beyond certain capacities, we could not do it. Early on, generalized intelligence looked possible, but human-like intelligence looked almost impossible. Even though we have computers for so many decades now, the entire human intelligence is far superior, right? So the entire computing possibility became harder than what we expected. We could not teach human intelligence into computers. Even though early neural networks were created in 1950s, and they were inspired by the biological neural networks that animals have, but this did not take off as expected, because one reason: the computing power that is required. You will understand during this course today how much of computation or how long it will take to train a neural network model. Imagine when you're doing that course, just try to imagine how it would have been around 50 or 60 years ago. It was impossible to create those neural network models that we are doing it today. And then one human architecture outclassed all these neural networks, and then what happened was expert systems came into picture. We could not proceed further with neural networks then, and expert systems were highly complex systems. They are programmed by the engineers, hundreds of thousands of lines of program, like if-else kind of structure. So if this is the case, do this. If this is the case, do that. So if as ladder, you can imagine such a thousands of lines of code. But these are programmed by engineers, and rigorous programming of many rules was required here. What happened with that? What is the limitation of this? Take a moment and look at these images and see what are these images. What do you just think of it? When you look at this image, when you just look at this image, you will see, this is a car, and this is a car, and this is the image of an ocean. But what happens in a computer? Computer will not understand the human level of perception. How do you teach children to recognize this? So you just looked at the image and said it's a cat. But think about it. How do you teach a child to say, looking at the image and saying it's a cat? Maybe a 2 years old kid will not be able to recognize a cat unless you show number of images of cats and say, oh, this is a cat. Even then, if a child makes mistakes saying, oh, this is a dog, and then you will say, no, no, this is a cat. So you are giving some feedback to this kid saying that how a cat looks like. But did you notice you're not going to tell that cat has 2 ears and 2 eyes and it has a tail, that's why it's a cat. No, we didn't do that way. So what we're doing here is we are showing the image of a cat and saying it is cat. So this is the way that we learn, humans learn, by exposing to a lot of data examples and give them the correct answer, even if they make a mistake when we correct them. And they'll pick up the important patterns on their own. Our human intelligence is designed in that way. And this is what we are trying to do with the neural network training process. So there was a period through the 90s and early 2000s where powerful AI appeared to many to be a pipe dream. So we could not achieve that. But today we are able to achieve a human level intelligence in many aspects of artificial intelligence. So two major things came together to bring up this revolution. What are those two major things? First one is the data. In order for a neural network to train and understand and perform to the human level accuracy, it needs a lot of data. It used to be in gigabits of data. Now it is in beyond TBs, or like you can't even imagine how big the data it is now. So the digital era and the internet has supplied that data for us. Everybody has a phone, everybody is on social media, we are creating content, such a faster pace. So the data is everywhere. But what about the computing power? The main reason that neural networks didn't take off in 1950s was because of the computing power. We need a way for our artificial brain to observe a lot of data and then within a practical amount of time. If it is going to take years to learn what is a cat, then I'm not interested in that, right? So these two are the major factors affected the revolution of deep learning. How computing power impacted the deep learning revolution. These two images, please look at these two images. This is a rendered image from a computer graphics. And this is a neural network, which we are going to train this network with lot of data, and then it will understand the patterns in the data, and then it will give us some output based on the training that we have done. So once the training is done on this neural network, when you give a new sample, imagine you train this neural network on thousands of cat images, and at the end you ask this neural network showing you again one more cat image and say, what is this? The neural network should be able to detect a cat in it. So this is how it works. But the major factor in the onset of modern deep learning was this processing power, right? So if we are this processing power, how we processed in CPU was completely different. How we process all these things in GPU. So it turns out that the neural networks are majorly matrix multiplication machines. So every operation that is done in a neural network comes down to a matrix multiplication. And where else do you observe matrix multiplication? In computer graphics based programs. So GPUs were built for computer graphics, and then slowly people started using GPUs to perform the matrix multiplications required to train a large neural network on a large data set. Then that became the revolution. So now we are able to process all the data which is available to us in very few minutes or a few seconds because of GPU technologies. So now, what is deep learning? What does it do? Why is it so special? Deep learning flips the traditional programming on its head. So how it works, you understand what I mean by it is flipping the traditional programming. When you want to build a classifier, what is a classifier? A classifier is a program that classifies two different things, if it is two-class classifier, or any number of classes. So what is the first thing we do in a traditional programming way? Define a set of rules for classification. So if it looks like one way, it is a cat. If it looks like other way, it's a dog. So that is how we define the rules, right? If it has 2 ears, if it is in this color, it has this texture. So this looks like a cat. Then program these rules into the computer. This is what we did earlier in traditional programming. We did examples and the program uses the rules to classify. Take one more example like chess. So chess has so many rules, right? So traditional expert systems hard code all these rules and said what is the next move to do. So this is the traditional way of programming. What happens in machine learning or with deep learning? What happened? So the entire overhead of defining the rules and coding the rules is given to the neural network. To model the examples with the answer of how to classify, and then model cases, we will tell if it is right or wrong. Now, after this process goes on for some time, then model learns to correctly categorize as it's training. The system learns the rules on its own. We are not going to give the rules here. So this is the fundamental shift. Earlier we had rules. If you take the image processing as example, we had hard code features in the images. We had to engineer all those features to define this is how a cat looks like, this is how a dog looks like. But now deep learning has taken all the burden on its head, and the neural network is going to learn the features or the patterns from the images and do the job for us. So when to choose deep learning? There's a major difference is classic programming and deep learning is to have rules or not, right? So if the rules are clear and straightforward, and often better to just program it instead of training a large neural network with large data. Even today, we still have some challenges of accessing the labeled data. By the way, data means it should be annotated or labeled. Otherwise, it's of no use to me. We'll have to find another way of using that data for neural network training purpose. So if the rules are not clear, if the rules are nuanced, so if you want to find the nuances in the rules which are specific to a data, and it is easier for us humans to do it, but machines will not be able to understand. So then we go for deep learning. If the rules are very complex and it is difficult to discern, and then use deep learning. If it is a chess program, 8x8, I can define the rules. If it is AlphaGo, it is a very complex board game, so deep learning is the way to do it. Even although most of the board games are driven by deep learning now. So deep learning compared to other AI. So AI is the bigger umbrella. Under that we have machine learning based algorithms, and in the machine learning based algorithms there is a new approach of deep learning. So how it works? Depth and complexity of the networks is far higher in deep learning models, up to billions of parameters, and it is growing day by day. Now it is in trillions of parameters. Parameters are the variables those values are learned during the training of the neural network model. And there are many layers in a model. So I showed you a sample neural network, right? Those circles are the neurons and the columns are the layers. And the number of layers in a neural network model keeps on increasing depending on the largest data set. And when we increase the layers up to some point, it will give better accuracy for us. You will understand all these things in the lab. And important for learning complex rules. So this is how deep learning stands out from all the other AI methods. How deep learning is transforming the world. The computer vision field has been around for a while, even before deep learning was born. And how it worked was there used to be some images or videos, and we used to write code to extract the features from the images. And now deep learning models, convolutional neural networks, or recurrent neural networks, all these things have come up and they are taken our job of handcrafting the features. They will learn their own features and patterns. So computer vision means giving vision to your computer. So through images and videos, is there any problem with the audio? Am I audible to all of you? Yes. Okay, thank you. What do you mean by vision now? So you have a vision, right? You look through your eyes and you understand what you're looking. If I show you a cat image, you will say, "Oh, this is a cat." So how it works pretty fine, but how will you teach this to a computer? So there's computer vision algorithms come into picture, and these are very, very critical for robotics and manufacturing units, and even for object detections, self-driving cars, everywhere. Wherever you see a surveillance video systems, you will need a smart vision system. So computers will be able to detect how many people are there in a room using the surveillance video. Or recent examples like in the COVID time, so many people came up with projects such as social distancing, whether it is maintained or not in public places. Surveillance cameras can do that for you. They can define some diameter of area around every person. If two people are coming very near to each other, then they can raise an alarm. So there is no end to the applications that we can think using computer vision. So are you using your smartphones and are you unlocking using your face detection based systems? Yes, that's the computer vision. It has reached the common man already. And very soon you will be able to see self-driving cars on our roads. The next one is natural language processing. The application is transforming our lives every day. So you might have already taken all these applications in your phone. You might be already using it. Are you giving voice notes? You're bored to type the entire long message in your WhatsApp. Are you giving voice input to your message, your phone? So that their natural language processing is there. So you visit any of the websites. So most of the websites nowadays are having chatbots, which are going to, you visit the website, they'll pop up some, I'm your virtual assistant. How can I assist you? So you might have already seen that. So have you seen a real-time translation application? Imagine if there is a person who does not understand English in this seminar today, in this workshop today. So I'm keeping in English and that person is not able to understand. If I give you a real-time translation machine, language translation machine, that person can be able to hear my voice, and in my own voice, he can hear what I'm talking in his own language. So real-time translation is the key here to bring people from all over the world together. And voice recognition, as I already told you, you've already started using it. And natural language processing is the most important topic after computer vision. So please pay attention. We have a lab practical also for natural language processing today. Next application that I would like to talk about is recommender system. We are already experiencing it. So the content curation, targeted advertising, shopping recommendations, there is no end to these possibilities that recommender systems are bringing towards us. Did you ever notice whatever you search on Google, you will get related suggestions in your social media scrolling? Yes, we are already there. And in Amazon, if you are shopping for something, it is going to show you related objects to purchase, right? So even if your Facebook, Instagram, or Spotify or YouTube are going to use recommender system, are going to show you the relevant content which you might be interested in. We have courses for recommender systems also in NVIDIA Deep Learning Institute. You can please take a look over there. The next one I would like to talk about is reinforcement learning. What is reinforcement learning? So you might have heard in news that AlphaGo beats the world champion in Go. This AlphaGo is a board game that I already spoke about. So how this happens? The robots, AI bots beat professional video gamers now. Now most of the video games are like played by the machines now. And even there are stock trading robots. There is no end of possibilities where we can deploy robots. In COVID times, people used robots for contactless delivery or contactless caring of patients in the hospitals. So there is no end for the opportunities, right? So how these robots are trained, how these robots are made to work in certain way? The answer is reinforcement learning. In reinforcement learning, at the end of this workshop today, I'm going to touch a little bit about how this is done. So we are going to train a machine saying that how to perform a task. If there is a wrong move, we will give a negative reinforcement. If there's a good move, we'll give a positive reinforcement. This is pretty much like how you teach a kid how to walk, right? So when you're teaching your baby how to walk, so or how to learn, cycling. So when there's a mistake, so you'll say, no, this way. So your child will absorb the reinforcement and then learn in a positive. So this is a major application of deep learning, and reinforcement learning is the way how these robots are trained. Coming to the overview of the course today, I hope I am able to connect you all with the course of this deep learning. I hope you are motivated enough to continue to learn how deep learning works in a practical manner. So this is the hands-on exercises course. You get comfortable with the process of deep learning here in this course, and you will get an exposure to different models and data types used in the deep learning model training. And then you can get a jump start to tackle your own projects. You can define your own projects. You will have the basic theory concepts or the tools that you need in hand at the end of this course. So the structure of the course goes like this. So there's a hello world of deep learning. I'll show you how it works. And then we train a more complicated model after hello world program. And then new architectures and techniques to improve the performance of this neural network will be discussed. And we can use one more concept called pre-trained models, which are somebody has already done the training that we are going to use the models for our purpose. Then there's a concept called transfer learning. I'll explain in detail when we go to that project. And then platform of the course is going to use GPU powered cloud server, and Jupyter Lab platform is used. If you know Python, you must have already used Jupyter Notebooks and Jupyter Labs. Jupyter Notebooks are interactive coding environment. So we will jump into the course. Software of the course, software is used in the course. You don't have to install anything for this course. Everything is available in the cloud platform. We have given you an instance of the cloud. Everybody, whoever has received the event code will get access to the computing environment. Major deep learning platforms that are available today for us is first one, TensorFlow plus Keras. Earlier it used to be only TensorFlow, or Keras was built based on TensorFlow or Theanos. Nowadays, everything is clubbed together. TensorFlow and Keras together from Google, they give you better access, or these are the frameworks that we require to code a neural network. Next option is PyTorch. This is by Facebook. This is very getting popular nowadays amongst the research community, even in the industry. And MXNet from Apache is also there. But for today's course, we'll be using TensorFlow and Keras. It's a good idea to gain exposure to others moving forward, but today we are going to use TensorFlow and Keras. The first exercise is to classify the handwritten digits. This is a good old problem. You can say a toy data set for deep learning models. Hello neural networks. How do we create a hello world program? Train a neural network to correctly classify handwritten digits. So if you show an image of a digit, handwritten digit, then our model should be able to detect what is the number. Historically important and difficult task for computers when these neural networks were created, or when expert systems were in place. This was a very critical job, and it was an unsolved problem or research problem. Now, it is a solved problem for most of the cases. And try learning a neural network. We will get exposed to the example and try to figure out the rules to how it works. We'll just jump into this practicals. Let's go to the practical. So before going there, before going to the lab practicals, meanwhile you people can please log into the course website. I've already given the event code. I request TAs to keep pasting it in the chat window repeatedly, so that everybody will get access to the course content. Before that, I would like to explain few things about NVIDIA Deep Learning Institute. We are conducting a regular cadence of public workshops for faculties and students. So this is the website. Can you see my website screen now? Okay, I'm going to reshare the screen so that you will see my Google Chrome. So this is NVIDIA Ambassador Workshop Series. We are continuously scheduling instructor-led workshops like we have it for today. So this is Fundamentals of Deep Learning, and it is again organized on 9th October also. And we have a specialized course for natural language processing where you will learn how to build NLP models using transformer-based networks. And then there's it was yesterday, and please keep watching this space for future workshops. One more thing I would like to show you is, this is the website of NVIDIA Deep Learning Institute. Here you will have online courses. Here you will get access to instructor-led workshops, and there are educator programs. So if you're a faculty here, please look at this. Please pay attention to this if you're a faculty. We have developed NVIDIA DLI teaching kits for educators. This teaching kits, you just have to request here. It is absolutely free. You just have to request using this button. You will get access to the contents, the entire course curriculum for deep learning, accelerated computing, robotics, data science, and recently graphics and omniverse. If you look at the course, I think everybody is aware of who is Jan LeCun, right? Turing Award winner. He's the topmost researcher in deep learning. He has designed our course, Deep Learning. So when you are teaching your electives for deep learning or machine learning, you can just download this kit from here. It will include all the lecture slides and the lab practical materials, quizzes, and whatnot, what else you need to conduct a course. Everything is included here, that too by the experts in the industry all over the world. So once you request for this, you can give coupons that we, the same one we showed you today, that event code I shared with you. Similarly, there are many online courses. You can get coupons for any number of courses and any number of students. You can request for these coupons. We will give you if you download this kit. And also we have provided lab practicals. If you need a cloud environment to execute those lab practicals in your college, so we are going to give AWS instance also for you to conduct the lab practicals. So what this teaching kit is giving you is lecture slides, lab practicals, and quizzes, plus the coupons to access these online courses for all your students, as many as you request, plus you will get a cloud computing platform to execute the programs in your lab practicals. So this is a great opportunity. Please make use of it. If you are a student, if you are faculty here, if you are a student here, please request your faculties and share this information. I'm going to give you all these links in the chat window. Okay. So next announcement is about the most awaited conference in the world, that is GTC, GPU Technology Conference, and this is going to be held on November 8 to 11. Please register using the link that I'm going to share in the chat window now. So this is completely free, more than 500 sessions, and the keynote is the most awaited keynote in the semiconductor industry. Our CEO Jensen Huang is going to deliver the keynote. He's going to announce all the latest technologies and all the new launches in the keynote. If you look at the speaker profile, you will see the best minds in the world speaking at this conference. Please register for this conference. It's completely free. Even after the conference is over, you can access all the sessions on demand. You can access previous GTC sessions also on demand. We conduct this conference 2 times in a year. Please visit this page and go through. And for any future collaborations and contacts, you can contact me. This is my email ID. I'm going to give all these things in the summary. Now, going to the course content.